Now, last time we talked about absolute value equations. Today we're going to be talking about absolute value inequalities. Now, similar to absolute value equations that have multiple solutions, absolute value inequalities can have multiple solution sets. Now, these inequalities, they have two different types, and they can be called either a conjunction or a disjunction, and this depends on the form of the inequality. So if you have the absolute value less than a number, then this is a conjunction. The solution here is going to be some form of an and statement, and when you shade it, when you graph it, you will be shading in between the two values. The other type, a disjunction on the other hand, is when you have an absolute value that's greater than a number. This solution is going to be an or statement, and when you graph it, you will shade away from each other. So they will be two separate solution sets. So how do you solve absolute value inequalities? You first want to start off by isolating the absolute value, just like you did with equations. Then you'll write two inequalities, just like you do with absolute value equations. You write two equations. So the first inequality is going to be the same inequality, just without the absolute value. And the second inequality, you take out the absolute value, you change the inequality sign, so you flip it, and you make the right-hand side negative, or the opposite. Now, after you've solved each inequality, you will write either an and or an or in between the two statements. To determine if it's an and or an or statement, you'll have to go back to the original inequality and see which form you have. Let's do some examples together. So here we have the absolute value of x plus 3 is less than 14. Now the absolute value is already by itself, so let's start off by writing the two inequalities. So the first one is the same thing without the absolute value sign, so x plus 3 is less than 14. Second one, we have x plus 3 is greater than negative 14. So we took out the absolute values, we flipped the inequality, and then we made the right-hand side negative. All right, now let's go ahead and solve each inequality. So we're going to subtract 3 from both sides. That leaves us with x is less than 11. And then for the right, we're going to subtract 3 from both sides, and that leaves us with x is greater than negative 17. Now if you look at the original inequality, this was in the form of a conjunction. That means I would put an and in between these two. That means that when I go about graphing it and shading it, I'm going to be shading in between these two values. So let's go ahead and put 11 and negative 17 on the number line. Now they are not going to be equal to it, it's just less than and just greater than. So open circles on both. And then everything that is both less than 11 and greater than negative 17 is everything in between those two values. So I shade in between the negative 17 and the 11. All right, let's look at example 2. We have 2 times the absolute value of x minus 5 is greater than or equal to 8. Okay, so start by isolating the absolute value. That means I have to divide both sides by 2. So the absolute value of x minus 5 is greater than or equal to 4. Now I'm going to write my two inequalities. So the first one, without the absolute values, would be x minus 5 is greater than or equal to 4. The second one, we're going to write x minus 5 is less than or equal to negative 4. All right, now let's solve both inequalities. So we're going to add 5 to both sides. And that gives us x is greater than or equal to 9. Do the same thing here, add 5 to both sides. That leaves us with x is less than or equal to 1. Now, if you look back at the original, we saw that the absolute value was greater than or equal to 4, which means this is going to be an or statement. It is a disjunction. So when we go about graphing this, we'll put the 1 and the 9 on the number line. Now, x has to be greater than or equal to 9 or less than or equal to 1. So we're going to put closed circles on both 1 and 9. And then because this is a disjunction, we are going to shade away from each other. So everything to the right of 9 and everything to the left of 1. All right, example 3. We have the absolute value of x plus 2 minus 5 is greater than 7. We're going to add 5 to both sides. That leaves me with the absolute value of x plus 2 is greater than 12. Now I can write my two inequalities. So the first one is just the same thing without the absolute values. So x plus 2 is greater than 12. And then the second inequality, this is going to be x plus 2, flip the inequality, is less than, make the right-hand side negative, negative 12. Now we'll subtract 2 from both sides. So now I have x is greater than 10. And in the second one, subtract 2 from both sides, so we have x is less than negative 14. Now because of the form in the original inequality, we know this is going to be a disjunction, so we will write this with an or in between. Now let's graph this, so we'll put 10 and negative 14 on the number line. From this inequality, we know that these are strictly greater than or strictly less than 10 and negative 14. So these are going to be open circles. And then we're going to shade everything to the right of 10 and everything to the left of negative 14. So we're shading away from each other in this disjunction. Okay, we have one last example. The absolute value of x minus 3 all over 4 is less than or equal to 1. Start by isolating the absolute value, so multiply both sides by 4. That leaves us with the absolute value of x minus 3 is less than or equal to 4. And then we're going to write our two inequalities. So the first one will be x minus 3 less than or equal to 4 without the absolute values. And the second inequality will be x minus 3. And then we will write greater than or equal to negative 4. All right, now we will add 3 to both sides. So now we have x is less than or equal to 7. And in the second inequality, add 3 to both sides, and we have x is greater than or equal to negative 1. Now this is a conjunction based on the original form. And now we can go ahead and graph this. So we'll put 7 and negative 1 on the number line. And because it is a conjunction, that means we're going to be shading in between. So x is less than or equal to 7 and greater than or equal to negative 1. Since they can equal negative 1 or 7, we can go ahead and put our closed circles on negative 1 and 7, and we will shade everything in between, and that is our graph.